All right, so Newton's second law, solving pulley problems. So here we have two situations where a pulley is involved. We have this mass on a table connected to a mass that's hanging off of a pulley. And then over here we just have two masses. We have two masses that run over a pulley where neither one of them is on a table. Okay, how do you solve pulley problems? Step one, you're going to do what? Free body diagram. Step two, you're going to sum your forces. Step three, solve the algebra from the equations that you wrote from summing the forces. However, for pulley problems, you have to be aware of a few things. So I have them listed out here. So first thing you have to be aware of, and arguably the most important thing, all of them are important, but number one on the list, you have to make the sign convention consistent. So here's what that means. If you look at this situation here, which way is M1 going to accelerate? To the right. M1 is going to accelerate this way. Okay? Which way is M2 going to accelerate? Downward. These accelerations, as far as their sign conventions go, these accelerations must agree with each other. So here's what that means. What we want to do is we want to say, to have those accelerations agree, we want to say for M1, we're going to say that this way is plus and that way is minus, right? You always want your acceleration to be in the positive direction. That's the nicest way to do it. You don't have to do it that way, but if you made your acceleration be in the negative direction, then A is going to come out negative. So I always set my problems up with the acceleration being in the positive direction. Okay, so this sign convention here rounds the pulley. It goes like this. It goes doot, 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 doot. It goes around the pulley. So over here for M2, we're going to have down as plus and up as minus. Okay, so the sign convention goes like this. It goes positive, 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 around the pulley, positive. The whole motion is one continuous positive motion. Does that make sense? You guys understand this? So it's like this. Let me just try to put it one other way. So the sign convention goes like this. Positive this way, positive this way, positive this way, positive this way. Okay? The sign convention goes around the pulley. All right, second thing on the list. The tensions on each object are the same. So if we look at M1, let me kind of erase these ropes here. So the ropes are there. I'm just kind of erasing them. Clean this up. All right, so over here we look at M1. Which way is the rope pulling on M1? To the left or to the right? To the right. So tension is to the right. Now if we look at M2, which way is the rope acting on M2? Up or down? Up. Tension is acting up, right? Because without tension, M2 would be in free fall. And you definitely cannot have a rope push you down. You know, like if I took a rope right here, here's, right here, ready? Like this. Can a rope push you down? No, a rope can pull you up. A rope can pull up, but a rope cannot pull you down. Wait, I said that wrong. A rope can pull you up, but cannot push you down, right? A rope is limp. Okay, now look at if we looked at the pulley. What's tension doing to the pulley? Like right here, which way is the tension on the pulley? Down. The tension on the pulley is down, and right here the tension would be this way. But are we focusing on the pulley? What are we going to be focusing on? The two masses, M1 and M2. Okay? Now the thing to know about these tensions is that they are the same, which makes sense because it's the same rope. This tension here and this tension here, it's the same tension. Okay? All right, number 3 on the list. The acceleration of the two objects are equal. Okay, the acceleration of M1, so M1 is going to accelerate this way, and then M2 is going to accelerate that way. These accelerations are equal. They're the same acceleration. Okay, that's going to be helpful in solving the problem. All right, and then last on the list, you have to specify the masses. You're going to be doing stuff like this. Free body diagram, you're going to be showing mg down. Now don't just say mg. You got to say what? m1g, and then over here this is going to be m2g. So why do you have to specify the masses? Because when you sum the forces, if you just say m, once you start working the algebra, you're going to be like, well, wait a minute, wait, is that this m or is that this m? So you got to keep track of your masses. The only time you don't have to do that is when? If the masses are the same. If it's the same, if the two masses are identical, then you can just say m. But if they're different, you got to say m1 and m2. Okay? So over here we got a very similar situation. So look, which way is m1 going to accelerate? So m2 is heavier than m1. So which way will m1 accelerate? Up. So we're going to say the sign, let's do sign conventions. For over here we're going to say up is plus, down is minus. Okay? Because m1 is going to accelerate up. Always make the direction of the acceleration positive. Now what's going to happen to this sign convention? The sign convention is going to go around the pulley. So what do we get over here?
Plus is down.
Down is plus, up is minus. It's one continuous motion. Okay? All right, and then tension up. You're going to have m1g down, m2g down. There's no normal force over here. These guys don't have normal force because they're not on a surface. Okay, so let's try a problem. Any questions before we do the problem? Okay. Okay, so here we have two masses, m1 and m2, connected by a string that runs over a frictionless pulley. So m1 is 5 kilograms, m2 is 7 kilograms. You're solving for two things. The acceleration of the system. Hey, what do we mean by system? System is m1 and m2 together, right? m1 and m2 will have the same acceleration, and what you're being asked to solve for in the first question is what that acceleration is equal to. Okay? So system just means m1 and m2 together. And then you're solving for the tension in the string. So if you do it correctly, the acceleration comes out as 1.6 repeating. That's the answer to number 1. And then the answer to number 2 is 58 newtons. The tension in the string is 58. Okay? So I'll give you 10 minutes. The steps you're going to follow again. Step 1, free body diagram for each mass. You're going to do a free body diagram for M1, then you're going to do a free body diagram for M2. Step 2, you're going to sum the forces for M1, and then you're going to sum the forces for M2. And then now you're going to have two equations, right? The two equations that you wrote in summing the forces, that's how you're going to solve the problem. So after step 2, it's just algebra. Acceleration and tension. Shh. How many of you got this right? Nice. I think that was the best of all the periods. Way to go. Okay, so let's clean this up. I'm going to take off. These are little acceleration vectors right here, just showing, M1 is going to accelerate up, M2 accelerates down. We don't need that. Take that away. And I'm going to erase part of the rope so we can get our free body diagram right in here. The rope's still there. I'm just, hiding it. Okay, so you start with a free body diagram with M1. So what are the forces on M1 here? We have tension pulling up, T up, and then what's pulling down? Don't just say mg, it's m1g. Now, to make this simple, so we know m1 is 5. In class, I use gravity as 10. When you're doing the homework, use 9.8, so then the answer matches with the back of the book. Okay, so m1g is going to be 50. Is everybody good with that? Yeah. That's 50 newtons, just because m1 is 5, gravity's 10, so that's 50 newtons. All right, so come over here to m2. What are the forces on m2? We have tension pulling up, and then we have m2g down. M2 is 7, so this is going to be 70 newtons. Okay? Now, sign conventions. Let's be real clear on our sign conventions. So, which way does M1 accelerate? Up. You always want your acceleration to be positive. So we're going to say that up is plus, down is minus. So that's our sign convention for M1. Now, what does that sign convention do? It wraps around the pulley, right? It's all one motion. So over here, down is going to be positive. Okay? Like that. So sign convention, you know, it's all one acceleration. It goes like this. Positive, 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 like that. Okay? So now let's sum the forces. So after you get your free body diagrams done, you sum the forces. Hey, and also, is there any normal force here? No, because both masses are hanging. Neither mass is touching a surface. So now what we do is we're going to sum the forces for M1, and we're going to sum the forces for M2. So for M1, here's what it looks like. So what are the forces on M1? Tension up, so that's plus, minus M1G, because why did I make M1G minus? Because it points down. But we know what M1G is. It's 50, so let's just put that in. So minus 50. And then anything else for M1? No. Nope. Okay, so what is the sum of the forces equal to? Mass times acceleration, where that's M1. Don't just say M. You got to say M1. So we just wrote a very useful equation. Okay, we're going to need that. Okay, now we go to M2. Summing the forces for M2, what do we have here? So remember, down is plus for M2. So you're going to go M2G minus T equals M2A. But we know what M2G is, right? What's M2G? 70. So let's just put that in. So we have 70 newtons minus T equals M2A, right? Hey man, both are these A's the same or different? Same. They're the same. And they're both positive, right? They're both positive because look, over here, which way does the A point? Up. Over here, which way does the A point? Down, right? So they're both positive. How about these tensions right here? They're the same. Actually, the tensions are equal and opposite. You know, this tension right here, this tension points plus, this tension points minus. But we already have that worked into the equations. Okay? All right, so what do we do from this point? From this point, we have two equations and two unknowns. So look, I'm going to get rid of the free body diagrams and do the algebra now. Okay, so we have two equations and two unknowns. What are the two unknowns? Acceleration is an unknown and tension is an unknown. If you have two equations and two unknowns, can you solve it? Yeah, this is like it's basic algebra. It's basic algebra. Okay, so let's do this. Let's find A and let's find T. So what I do, I go like this. Take this equation, solve it for T. T equals M1A plus 50 newtons. Then take this equation, solve it for T. T equals 70 newtons minus M2A. So guys, we have two equations for T. What do we know about these T's here? Same or different? Same. So that means that this and this must be what?
Equal.
Equal. In math, I think there's a name for that. The transitive property? What's that called? You guys are you're better at math than I am. Like if A equals B and B equals C, that means that A equals C. Remember that? What's the name for that? Is that transitive? Whatever it's called. We'll just call it common sense here. If the T's are equal, that means that this and this are equal. So now you go like this. Now you go M1A plus 50 newtons equals 70 newtons minus M2A. The only missing thing in there is A. So now you got to get, you got to get everything with an A to the left, everything without an A to the right. So that becomes M1A plus M2A, and then the 50 and the 70 simplify to 20. Okay, then factor out an A. A M1 plus M2 equals 20 newtons. What's M1 plus M2? Add the two masses. What do you get? 12. So this is going to be A equals 20 newtons divided by 12 kilogram. Now remember, what's a newton? Kilogram meter per second squared. So what happens to the kilograms? They cancel, and you get 1.6 meter per second squared. 1.6 repeating. Okay. Now, once you have the acceleration, how do you find the tension? Well, you go back up here. Look, you have two equations for T. You can pick either one. Either equation will give you the answer. So take the first equation. So T equals M1A plus 50. So M1 is 5. A, we now know, is 1.6 repeating plus 50. This comes out as 58 newtons. Right? Or you could have plugged into this equation. You could have plugged into that. So any questions on this? So it's pretty straightforward. The things to remember: sign convention rounds the pulley, tension and acceleration are equal, right? And then specify your masses. That's how you do a pulley problem. Tomorrow, what we'll talk about are incline problems. How to solve problems where the surface is not horizontal. It's a hill. A skier down a hill. A car on a hill. Spaldo skateboarding down a hill. Did I tell you guys about my skateboarding weekend last weekend? I kind of got back into skateboarding. I'm not real good at all, but it's kind of fun. All right.